Last year, we have developed and released RotoPD, which works up to 30 volts, but we want to make something better. Introducing RotoPD Pro now supports up to 48 volt or 240 watts. To learn more about the project itself, you can check out our Hackaday page, or go to our GitHub for hardware files, where you can find documentations, schematic, and KiCad files. Let's take a look at some chargers that support AVS. This is a newer profile that supports in Power Delivery version 3.2. For this video, we will be using Framework 240 watt charger. It supports all of the fixed profile up to 48 volt, AVS profile from 15 to 48 volt at 5 amp with small voltage increments. Let's start with soldering on our terminal. For USB-C cable, you need to make sure you are using a 240 watt rated cable. Sometimes it says on the cable, sometimes it printed on the connector itself. To start, you first need to install the library called AP33772S. Here I have the version 1.2, which have this serial command example that is written for Roto PD Pro that you can use. I already have it flashed to a ESP32C3. So let's see what we can do with serial output. So we have the charger already plugged in, and I'm gonna type profile. This displays all the profile that the charger support. You got 5, 9, 15, 20, 28, 36, 48 volt. So this is what we call fixed PDO, fixed profiles. And then you have an adjustable profiles called AVS, stand for adjustable voltage supply. And the range is from 15 to 48. So let's try the fixed PDO. You can type in set PDO. And here I would like to do profile 2, which is 9 volt, and I do 9, and you should see it going up. And if I do set PDO 3, you should see it negotiate 15 volt, and similar, I can go all the way up to 48 volt. In here will be PDO 10. We also can read the output voltage and the current. You can type in stat. It will print out the bus voltage is 47.92 volt. And to tap on the AVS profile, we can type in set AVS and type in the voltage that you want. So here I can do 20 volt. And you can get the 20 volt. .30 volt, and I can set the output to be on, which you can see the LED is turning on. That indicates the output is now active. However, there's no load. I put some load onto the system, so I want to lower the voltage down to 16. For the load, let's start with 5 volt. And turn on. Now you see there's some current conducting, about 3 amp. Yeah, I can type stat. You should be able to see 3 amp in current. So now I want to show you guys a new feature. It's called Overcurrent protections. So you can type in set OCP. And default, the code will set it up to maximum of 5 amp, but you can set it to a lower value. So here it's currently running at 3 amp, so I can set it to 3 amp and a half. And here, if I increase our current, eventually it will trip. So since I have a fixed resistance, I can increase the voltage to cause a trip. So here I can set it to 20 volt, and you see the output turn off. Right, and you can confirm it with stat. You can see at the input of the USB-C, we still have 20 volt, but now the current is 0. Output switch in Roto PD Pro is slightly different. It is controlled by both the PD controller and the current sensor. This allows us to set an overcurrent limit, and then the INA238 will disable the load switch when the limit is reached. This also means that we need to clear the error before we can regain the control again. Here you can see the only time the load switch can be turned on is when the PD controller output is set to 1 and the INA doesn't have any error. Let's get back to our example. We have the input voltage is 20 volt and attached load as 5 ohm. So we know that if we re-enable the load switch, and even if we clear the flag, we're still going to run into the overcurrent protections. So step 1 is we need to make sure that the PD controller is not controlling it. Right, type off, and then we're going to lower the voltage to 15 volts. So when we turn it back on, it will be below the threshold. Oh, set AVS. Okay, and now I can do clear. So this clear signal is clearing the error flag in the INA. Now if I type on, the switch should be able to turn back on again and conduct in 3 amp. Why is it running? You can turn it off, and you can turn it back on again. And whenever you need current protection, just type set OCP. Here I can set to 2 amp, and again, it's below what we are using, so it will turn off. Well, that's it for Roto PD.